Hi friends, welcome to Edumendo. Today we will be learning the first topic of digital logic, that is Boolean Algebra. Before going on to the topic, let me tell you one thing. The standard textbook of digital logic, you can follow Anand Kumar, Digital Logic by Anand Kumar, and you can go for the 4th edition of it. Okay, now let's move on to our topic, Boolean Algebra. What's Boolean Algebra? How is it different from normal algebra? I'll show you. Here you can see that in normal mathematics we will write x plus y is equal to z. Here we can see that the variables x and y are known as the operands or just variables, and this plus sign is the operator and this z is our final result. In case of normal mathematics, this x and y, the variables x and y can have any values in between minus infinity to infinity, plus infinity. That means x and y can have any values like positive integer, a negative integer, a decimal value, fraction value, etc. It can have any of these values. Likewise, the final result z can also have any of these values in between in minus infinity to plus infinity. But in case of Boolean algebra, these variables x and y are known as binary variables. What do you mean by a binary variable? Binary variable means a variable which can have only two values, that is either 0 or 1. That means the input values as well as the final result will be one of these values, either 0 or 1, or also we can write it as true or false. True means 1 or the high value and false means 0 or the low value. So in case of Boolean algebra, the input signals as well as the output signal will be a stream of zeros and ones. Thus we can conclude the definition of Boolean algebra as a system of algebraic notation represented by means of zeros and ones. So, Boolean algebra is a system of algebraic notation represented by means of zeros and ones. And in question paper, if you are seeing a term switching algebra, don't get confused. It's nothing but Boolean algebra itself. So, Boolean algebra is also known as switching algebra. Now, let's look at the basic operators of Boolean algebra. The three basic operators are AND, denoted by a dot, OR, denoted by a plus, and NOT, denoted by an apostrophe. This AND is analogous to the symbol conjunction as well as intersection. Likewise, the OR is analogous to the symbol disjunction or union. And finally, this NOT can also be represented as using this symbol or a bar on top of the variable or even this symbol. NOT is also known as complement. Now let's look at each of them. First we can go through AND operator. AND is a binary operator. That means it should have two variables. For example, let's consider those variables as x and y. And let's assume that their output is z. So the inputs are x and y and the output is z. So we can represent the AND operator as z is equal to x and y, or simply we can write it as z is equal to x and y. In case of AND, it's not compulsory to put the dot symbol in between. If you simply write xy, that means x and y. Now let's look at the truth values or truth table of AND operator. Here this is our input variable x, this is our input variable y, and this is our output variable z. In case of AND operator, the output variable z can have the value 1 if and only if both of its input x and y are 1. That means the value of z can be 1 if and only if the value of x and the value of y is 1. So here in the truth table, if the value of x is 0 and y is 0, that means the value of z will also be 0. If the value of x is 0 and value of y is 1, then also the value of z will be 0, because For the value of z to become 1, both of their input x and y should be 1. Here only y is 1, x is 0. Similarly, if x is 1 and y is 0, then also the value of z will be 0. And if the values x and y are both 1, in that case, the value of z will be 1. This can also be represented using a Venn diagram. I hope you all will be knowing what a Venn diagram is and how to draw it. So this is our Venn diagram and this is our universal set. And our inputs x and y. So this is x and this is y. So this is the elements or these are the values of input variable x and these are the values of input variable y. And the area in between these means it's the values that are in x as well as y. So x and y means this area. This represents our z is equal to x and y. That means the variable z will be having the values which are in x as well as y. Now let's look at the next operator, OR operator. OR operator represented by plus. This is also a binary operator. That means OR operator also have two variables. We can write it as z is equal to x plus y. We will read this as z is equal to x or y. That means the values of the variable z will be the values that are in x or in y. The operator OR will be having the output as 1 if either of these input variables x or y is having a value 1. We can look at it using our truth table. This is our input variable x, this is our input variable y and this is our output variable z. That means x plus y. So if the value of x is 0 and y is 0, so the output value z will also be 0. If the value of x is 0 and the value of y is 1, then our variable z will become 1. That means either of these values x or y, if either of these values become 1, then the result will also be 1. If x is equal to 1 and y is equal to 0, in that case also the output variable z will become 1. And if x is equal to 1 and y equal to 1, in that case also the value of z will become 1. So here we can see that the value of z is 0 if and only if both the variables x and y are 0. In all other cases, the value of z will be 1. Now I will show you the Venn diagram of OR operator. So this is our universal set. This is the values of our input x and these are the values of variable y. So x plus y or x or y means the values that are in x or in y. So all the variables that are in x will be included in z as well as all the values that are in y will also be included in z. So this entire shaded area, this will become our z. Z is equal to x or y. Now let's look at our next operator, that is NOT. Unlike and OR, this NOT operator is a unary operator. So what is unary operator? We said that binary operator means there will be two variables here, x and y. Two variables are there along with the operator. But here in case of NOT, NOT is a unary operator. Unary operator means along with the operator there will be only one variable. That is, we can write it as x complement or we can write it as x bar or we can write it like this or even this. All these representations represent the same thing, that is x bar or x complement, or we can say the negation of x. So if the value of input x is 0, then the output will be 1. And if the value of input x is 1, then the output will be 0. That means whatever we are giving as the input, the output will be just the toggle of that. That is the complement of the input. So the truth table of NOT will become something like this. There will be only one input x and the output value z will be the complement of x. So if the value of x is 1, then the output will be 0, and if the value of x is 0, then the output will be 1. In Venn diagram, this can be shown as if this is our universal set and these are the values of input variable x. Why I have drawn only one circle? Because as I said earlier, note is a unary operator. So only one variable is there. So we have to show only one circle representing that single variable. So if this is the values of x, then the output z, that means x complement, will be the values that are not in x. So this shaded area will represent the values that are not present in x. And this is our output z is equal to x complement or negation of x. So that's all for today. So now we have seen what's a Boolean algebra, how it is different from normal algebra, and also we have seen the basic three operators of Boolean algebra. The other operators of Boolean algebra includes NOR, NAND, XOR, and XNOR. We will see these operators in the upcoming classes. In the next class, we will be learning about the properties of Boolean algebra. So that's all for today. I hope you have enjoyed the session. If you have any feedback or suggestions, please do tell us. See you in the next session. Thank you.